All right, now we're going to look at something called differential equations. We've already sort of done this a little bit, so it's not really that new. It's just we haven't really officially named it or talked about it, so we'll do that now. And so what you have here is what we would call a differential equation. It's an equation that is not y equals or f of x equals, but you can think of it like a rate. It's a derivative equals something. Okay, and what we want to do to solve it, we talk about solving them, is to find the solution to a differential equation is to find the original function from which it came. Now we know when we integrate that we're just finding the change in the original amount. It's not, we don't know what the original amount is. We're just finding the change in. We need that also that initial amount to add to it. So this is going to help us get our actual y values, because we're given what we would call an initial condition, okay? Meaning it doesn't have to really be f of 0. Sometimes people think initial means, times 0. It just means it's a condition. It's 1 point on the original curve, if we're thinking graphically. So something to think about, first of all, is just before we get into this, if I gave you a differential equation, I don't know, say 2x. If I asked you what would y be, that would be the solution to that. We would say that it could be x squared, or it could be x squared plus 4, or it could be x squared minus 8. It could be x squared plus any constant. We've talked about this before. So a lot of times you'll see the family of curves graphed. So if x squared looks like that, then the family would just be that x squared shifted up or down. And we don't know which one is the real curve until we have use our initial conditions. So we can say it's the one that passes through. So in this case, maybe I gave you initial conditions of the point 2, 4. So I'd find the curve that's got 2, 4 on it, and that's actually the parent function, right? Because if I plug in 2, I get 4. So this would be our winner, but I don't know the particular solution until I have that initial condition. So this would be our general solution. Whoops, just giving you some terms. That's our general solution. On the graph, it would look like a family of curves that are all doing the same thing or have the same shape. The particular solution would be the one when we figure out what the constant is. So we want to find or solve these differential equations using particular solutions. And we're going to look at it two ways. In this section, we're going to just look at it algebraically. How does that work? All right, and here I found a picture online that maybe gives you a little better view of what I'm talking about. So here's the family of solutions. It could be any one of these curves. I need to know an initial condition. Like I need to know, if I told you an initial condition is that the original function f of 0 equals 1, then I would know that it's this top curve here because it passes through 0, 1, and that's the particular solution. So once you know a point on the original, you can come up with your particular solution. All right, so let's do it here when we have the equation. Thinking about the graph is helpful, but we want to be able to do it without the graph. So the first thing you do is what's called separation of variables. I multiply both sides by dx. And what that does is it gets all my y's on one side of the equation, all my x's on the other side. And that allows me then to integrate both sides of the equation. So now when I go to integrate both sides, you can think of dy as 1 times dy. So I apply power rule here. The integral of 1 is just y. Over here I apply power rule, x to the third, and then 6 divided by 3 is 2. And then x squared, I divide by that, I get 3 plus 2x plus c. This would be my general solution. I just found what y equals from the differential. Okay, so that's my general solution. That would be that family of curves, an x to the third. So it would be a cubic, and that plus c says it can be shifted up or down wherever I want it to be. Now I can use my initial conditions to find my particular solution. So these are our initial conditions. We can use those to find our particular solution. When y equals 2, and x is -1, that's the curve we're talking about. All right, so we solve this for c. We get 2 equals -2 plus 3 minus 2 plus c. So it looks like -1, I add 3. It looks like c is equal to 3. So f of x, I rewrite it now, my solution as 2x cubed plus 3x squared plus 2x plus 3. And that is my particular solution. I know exactly which curve it is now. All right, so remember that general solution's got a bunch of graphs on it. They're all the same shape, but they're shifted up or down, and there's infinitely many. And then the particular solution is picking out which one it is, because I know that this line, that point lies on it, and there's only one curve that goes through that point of all my general solutions. And it's this one right here. Okay, so let's try this next one. We do the separation of variables. We multiply both sides by dx. I get dy equals 1 plus 12x to the 3/2 over 2x to the 1/2 times dx. So now I want to integrate both sides. I'm not going to integrate the left side yet because I'm not ready to integrate the right side yet. So maybe I will, to show you that you can kind of do it in parts. So over here, when I integrate my y, my dy, I get just y. Over here, I'm not integrating yet, so I'm going to leave it as the integral. I'm going to distribute this division because I'm dividing by a single term. So I can think of it as 1 over 2x to the 1/2 plus 12x to the 3/2 over 2x to the 1/2 dx. So now I'm going to say y equals the integral of 1/2 x to the -1/2 plus 6x to the 2/2, which is just 1 dx. From here to here might be a little bit tricky, the algebra. Sometimes students get confused. So what I want to do is I want to apply power rule. X is in the denominator, so I'm going to bring it up to the numerator, and then I kick it out of the fraction. The 2 does not move with it. The 2 has its own exponent of 1. The 2 stays down below. We kick it out of the numerator then, the x, because I want to have it in the form coefficient times x to a power, so I can apply power rule easily. All right, so now I can integrate this finally. So if I increase the power by 1, I get x to the 1/2. I multiply by the reciprocal, so 1/2 times 2 over 1 is just 1. Plus, I increase the power by 1, so then I divide the 6 by 2, and I get 3. So then it's plus c. So this again, remember, is my general solution. I can use my initial conditions to come up with my particular solution. Let me just make sure I have all this right. I do. So I'm going to plug in 2 for y and 0 for x. I end up getting 2 equals c. So now I can rewrite and get my particular solution is the square root of x plus 3x squared plus 2. Write that 2 a little better. All right, let's try another one. Separate my variables. So I multiply both sides by dx, and I get dy equals x squared plus 2x over 2y dx. I did not finish separating my variables because I noticed I still have a y over here. So at the same time that I multiply my dx to both sides, I can multiply the 2y on both sides. Some people say cross multiply. Some people do it in 2 steps. So if I'm doing it in 2 steps, the next step is to multiply both sides by 2y. So I get 2y dy equals x squared plus 2x dx. All right, so now I am going to integrate both sides. So I've got the integral of 2y. I can apply power rule to that thing. So I'm going to get y squared divided by the 2 is just y squared. I do power rule here. I get 1/3 x cubed plus x to the second divided by 2. It's just a 1 plus c. That's my general solution. So now I can leave the y squared there, or I guess I can square it both sides, but I'm going to leave it for now. So I'm going to then find my initial conditions, which are 0, 2 again. So if I plug in 2 for y and 0 for x, I end up getting c equals 4. So then my final solution is y squared equals 1/3 x cubed plus x squared plus 4. And we want it in terms of y equals. So what's going to happen here is I can square root both sides. So I'm going to get plus or minus the square root of 1/3 x squared plus, that shouldn't be x squared, that should be x cubed, sorry. 1/3 x cubed plus x squared plus 4. And it's the square root of that. And now we want a function, so this is not a function because it's two outputs, a positive and a negative. You got to choose which one is the correct one. And so we're going to talk about how to do that. So again, your initial conditions can help you do that. So remember, our initial conditions, it passes through the point 0, 2. So, it's skipping again. So if I plug 0 in for x, I'm not going to do that. We can kind of do that in our head. You just think about it. You get the square root of 4, which is 2, and it's either plus or minus 2 are your two choices. So we're going to go with the positive version because we want it to end up y being 2, not negative 2. So it's got to be the positive 1/3 x squared, x cubed. I keep doing this x squared thing. 1/3 x cubed plus x squared plus 4. We choose the positive one there. So that's an important step to note. It'll come up again, so we'll see how that works out. All right, so here's number 4. I'm going to say pause the video and see if you can do it on your own. All right, so you should have gotten this. Now, I should have been writing these in f of x, not y equals at the end, because since we have it as a function solved for y, we might as well write it in function notation to say that it's a function. I forgot on these last two. I can only put the f of x in here at the last step because it's not a function until then. Once I eliminate the negative version, then it becomes a function. So keep in mind here, I got down to y equals plus or minus the square root of x squared plus 4x plus 4. And why did I choose the negative version this time? Because when I plug 1 into this, I get 1 plus 4 is 5 plus 4 is 9. So I'm getting the square root of 9, which is 3. So I'm getting plus or minus 3. We want, our particular solution says we want the negative 3. So that's why the initial conditions make the negative version work. So that's our solution. All right, let's do a couple more here. So first you start by separating the variables. So we're going to multiply both sides by dx. So I got dy equals x to the 4th y minus 2 times dx. Our variables are not separated because I still have some y's on the right side. So I divide by y minus 2. And I'm going to write this as 1 over y minus 2 times dy equals x to the 4th dx. So you've done your separation of variables. So now we want to integrate both sides. Looking at this left side, this is going to be one of those pattern recognition ones from our last section. So remember, when I have a fraction, I'm looking for like a u. If the bottom of the fraction is to the outer power of 1 like that, I'm looking for like a u prime over u situation because it's probably ln of u when I integrate it, right? So if my inner function is y minus 2, what's the derivative of y minus 2? It's 1. So I notice that the derivative is the numerator. So this is going to be one of those reverse chain rules, and it would have been the natural log of the absolute value of y minus 2. So if you're having trouble with this still, talk to me in class about it. But you're trying to recognize u prime over u. You got to watch out for that one. So it's the natural log of the absolute value of y minus 2. On the other side, it's a simple power rule. So we're getting 1/5 x to the 5th plus c. All right, so now from here, this is our general solution. Keep that in mind. And we want to use our initial conditions to look for a particular solution. Okay, so then we're going to take a moment here to find out what C is. So we're going to plug in our initial conditions. There's different ways to do these now because you then have to solve for y afterwards. So we're going to always find C before we move on and solve. I think it's just easier to do that. I mention it because when you start looking at some of the College Board rubrics, you might not know what they're talking about. They have a C sub 1, a C sub 2, and we'll talk about that when we come across it. But for us, we're going to stop and solve for C right away. So we plug in 0 for x, we plug in 0 for y, and we get the natural log of the absolute value of -2. Here's where that absolute value becomes key. 0 times 1 is 0, so it's going to be C equals the natural log of the absolute value of -2. So we're just going to say that C equals the natural log of 2. So now we can rewrite our general solution to get our particular solution. The absolute value of y minus 2 equals 1/5 x to the 5th plus the natural log of 2. Remember that this is just a number, the natural log of 2, just like pi is a number. All right, so now they want us to write it, though, in function notation in y equals form. So y is inside a natural log, so if we e both sides, that means the left side we get y minus 2. Right, I'll say the absolute value of y minus 2 equals e to the 1/5 x to the 5th plus the natural log of 2. So what we're going to want to do here is kind of apply the properties of logs in reverse. And that's helpful because it's going to help us deal with that e to the ln of 2 thing in this case. So what we have is the absolute value of y minus 2 equals e to the 1/5, x to the 5th times e to the ln of 2. Remember that when you multiply bases, you add the exponents. So that's why, because I see addition of the exponents, I can write it as times e to each exponent. So we're kind of doing this. If I saw like x to the 2 plus 3, I can write it as x squared times x to the 3rd, because that's the reverse of the property. The way we usually use it is if we see x to the squared times x to the 3rd, we add the exponent. So we're kind of doing that in reverse. The reason why that's nice is I can then write this times 2. All right, because e to the ln it just cancel out. So now I've got the absolute value of y minus 2 equals 2 times e to the 1/5 x to the 5th. So now what we want to do is we've got two solutions here. We've got y minus 2 equals 2 times e to the 1/5 x to the 5th, or it could be y, we'll look at it this way, negative y minus 2 equals 2 e to the 1/5 x to the 5th. So remember, absolute value means you have the positive or the negative version. You just got to keep it in parentheses. Here I don't need to show the positive parentheses part because it doesn't really do anything to it, right? So now we solve each equation for y. So on this one I got y equals, if I add 2 to both sides, I have 2 plus 2e to the 1/5 x to the 5th. Or my solution could be, instead of distributing this negative, what I'm going to do is divide both sides by a negative. So I've got y minus 2 equals negative 2e to the 1/5 x to the 5th. I add 2 to both sides, and I'm going to get 2 minus 2e to the 1/5 x to the 5th. X to the 5th is in the exponent. So which one is the winner? Well, here's where you can use your initial conditions again and see which one works. So when we plug in 0 for x, we should have gotten 0 for y. So we know that e to the 0 is 1. So when I plug in 0 here, I get 2. So e to the 0, this becomes e to the 0, which is 1. So I get 0 equals 2 plus 2, which is false. Or when I plug in 0 here for x, I get e to the 0 is 1. So I'm getting 2 minus 2 is 0, and y is 0, right? If I plug in 0, my initial conditions were plug in 0 and 0. You can see here when I plug in 0, I do not get a true statement. I get 0 equals 4. Here I get 0 equals 0. So that's our winner. That is our particular solution. It's going to be 2 minus 2e to the 1/5 x to the 5th. All right, so let's look at another one here. So if how are we doing here on time? 20 minutes? Not horrible. I separate my variables. This one's a little trickier because we'll see what happens when we try to separate the variables here. We got to watch out. We get the variables are kind of like crossed up. So we got x squared dy equals y minus 1 times dx. So then we're going to divide both sides by x squared. So we'll get dy equals 1 over x squared times dx times y minus 1. And then I'll divide both sides by y minus 1. So I'll get 1 over y minus 1 dy equals 1 over x squared dx. So now I'm ready to integrate both sides. Again, when I start seeing these fractions, if I see an inner function to the power of 1, I'm thinking u prime over u. So what's the derivative of the inner function here? Y minus 1 is just 1. So this does look like u prime over u. So this is the natural log of y minus 1, the absolute value. So we're dealing with that again. Equals, on this side it's just power rule because the power is not 1. The power is x squared and there's not an inner function. So I'm going to rewrite this as the integral of x to the negative 2 dx. I'm going to apply power rule. So here I'm just going to carry along. I've already integrated the left side. On the right side, I'm going to apply power rule, and I'm going to get negative 1 over x. When I do my power rule, and then plus c. I like to kind of stop and make sure we know this is our general solution, because now we're going to take a little time out and solve for c. So we're going to plug in our initial conditions, which are 2, 0, because it said f of 2 equals 0. So we've got the natural log of 0 minus 1 equals negative 1 over 2 plus c. So we want to solve this for c. We get the natural log of the absolute value of negative 1 equals negative 1/2 plus c. So this is going to be the natural log of 1 equals negative 1/2 plus c. I'm going to add 1/2 to both sides, so I'm going to get the natural log of 1 plus 1/2 equals c. So then we know the natural log of 1. Hopefully that's going to be a natural log you need to remember. The natural log of 1 is always 0. So c in this case equals 1/2. So now I can write my particular solution. I go back to my general solution and rewrite it out. The natural log of the absolute value of y minus 1 equals negative 1 over x plus 1/2. That is our particular solution. So then from here, they want us to write it as a function, so we've got to solve for y. It's going to be kind of more of the same of what we just did. So let's go through these steps again. So we're going to e both sides. So on the left side, we're going to get the absolute value of y minus 1 equals e to the negative 1 over x plus 1/2. And then what we can do is we can break up that e part. So the absolute value of y minus 1 equals e to the negative 1 over x times e to the 1/2. Okay, so then from here, we're going to say, we can look at this a couple of ways.